Hey guys, I'm Paul Brodie and today I'm asking all the questions about turbochargers, and I'm here at Turbo Performance Limited talking to the man himself, Mr. Mark Arnold. I've got a list of 10 of the top questions to be asked in all things turbo. I'd like to begin, if I can, with someone comes through the door and they present with the seals on my turbo have gone.
Yeah, the phrase "the seals have gone in my turbo" is something that I hear probably 10 times a day, and I'm sure anyone in the turbo business is in the same boat. People imagine all kinds of different things, but the seals, let's call them that, in a turbocharger are a square section piston ring at either end of the centre shaft. The piston ring has a gap in it of about 5 thou. There is no positive oil seal, there's no O-ring, there's no device like that. The piston ring acts as a pressure differential seal. It relies on back pressure and boosted air pressure to retain the oil within the turbo. So if your turbo is leaking oil and if the seals are gone or worn, it's because there is a problem elsewhere. Either the journal bearing system has worn and allowed excessive radial play, or the thrust bearing is worn and allowed longitudinal movement. The shaft would have to move in order to wear those seals so that they might leak. So when someone is saying the seals are gone in my turbo, they're presenting a symptom, not the root cause of it. We can take a turbo apart and have a look at those if that's useful. This is the centre part of a turbo, what we would call a core, or technically the CHRA, centre housing rotating assembly. So this is the compressor wheel and this is the turbine wheel. That's being driven by the exhaust gas and that is doing the compressor work. So the only reason I've highlighted this is because I want to talk about this part, and that gives you some perspective on what we're looking at. So the centre shaft that connects the turbine wheel to the compressor wheel at either end has a piston ring, and this is the piston ring here, and this is the piston ring here, and this is the entirety of the oil sealing arrangement in a turbocharger. This part here and here are the journal bearing surfaces, and this is the thrust collar that controls the longitudinal movement. And so inside the other housing, what you would have is two of these journal bearings that sit there and there, like that. And this fits on there like that. So that's what the turbocharger rotating part looks like inside the other housing. So the job of this bearing is to stop the radial movement, like that, and the job of this bearing is to stop the longitudinal movement. So for as long as those two are holding this shaft in the middle, this piston ring and that piston ring stay stationary, held by the outer housing. They don't move. This rotates within it. And so without the movement of radial or longitudinal wear, there is nothing to stop this piston ring staying as it is. So something has to act upon it. So when someone says the seals have gone in my turbo, what they're talking about is the result of movement in either of these planes. Hopefully that helps explain.
Is it at all valuable to fit a turbo to say a 1 litre Saxo? Would you get any performance difference from it? Is it worthwhile doing that?
Almost any internal combustion engine can be turbocharged. The question that would be more relevant to your small car owner who wants to boost the performance of their vehicle is, how much is it going to cost me? So to retrofit a turbocharger to an engine that didn't already have one, you could be looking at 10,000 quid for that project. So in the case of a 1 litre Saxo or a small cheap car, it's just not financially viable. You can go and buy a faster car for less money that you're going to spend turbocharging it. So unless you're doing it out of love or out of some other, you want a project or what, you know, it can be done. It's just that it can be very expensive and isn't always worthwhile.
What in your experience are the most common turbo failures?
So, splitting the world of turbocharged vehicles into two, let's say there's the performance market and then there is the run-of-the-mill diesel car market.
Right.
In the performance market, the common failures would be excessive exhaust gas temperature, melting the turbine wheel of the turbo. That can be a mapping problem or a fueling problem or an ignition problem, but the exhaust gas temperature has gone so high that it has melted the turbine wheel of the turbo. We see that fairly commonly. And secondly, the bearing system being damaged due to oil contamination, often because of some other part of the engine is wearing and that metal swarf makes its way through the turbo and wrecks the turbo. So oil contamination and EGTs are probably the biggest killers in the performance market. On the run-of-the-mill family road car type situation, again oil contamination, but more usually because of a lack of servicing or excessive service intervals. And because cars on the street these days, they're not made to last, everything is cheap, you see problems like intercoolers with plastic end caps, cheap and nasty pipework. This isn't the car's owner's fault, this is just the reality of cars on the road these days. Those parts begin to age, the pipes become hard and brittle and break, and the intercooler end caps can blow out of intercoolers and cause leaks. Any of these air leaks will cause the turbocharger to overspeed, and we see an awful lot of turbochargers with overspeed failures on common and garden road cars. So oil contamination and overspeed being the two favourites for the road.
Are we in a better position to think of a turbo unit as a construction of parts much as we think of an engine?
Again, with a performance car turbocharger, I think you can think of the whole turbo as one item, separate to the engine and one item to itself. With a road car, you could perhaps think of the turbocharger as one part and the boost control system as being a separate part, because we have issues with VNTs and things like that, which we can come to later. But that's how I would look at it.
How long should we expect a turbo to last?
The bearing system in a turbo, the journal bearings, it's a floating bearing system. There is a layer of oil between the centre shaft and the bearings, and another layer of oil between the outside of that and the housing. And the impellers, the exhaust side is in the exhaust gas flow. The compressor draws in clean fresh air and compresses it and puts it in the engine. There's no metal to metal contact on any of these parts. There is nothing that wears. So for as long as that turbo is fed clean, debris-free oil, and the air it's drawing in is free from dirt and dust and debris, and the exhaust gas is clean, there is no reason that that turbocharger wouldn't last the entire length of the engine. The reason they don't is they are usually killed by outside influences, be it dirty oil, dirty air, whatever. But yeah, theoretically, if you could run that turbo on good, clean, fresh air with clean oil, it would last forever.
Codes now. VNT, what does that mean, and what is limp mode?
Almost every single car that's diesel will have a turbocharger on it. That's a very common thing. And VNT, it stands for variable nozzle technology or variable nozzle turbocharger. That is a form of boost control. On petrol cars and on more old-fashioned diesels, there was a simple wastegate open and shut valve arrangement. On these more modern cars, they have a variable nozzle system that controls the boost control. Now, if you put a large number of moving parts that are relatively delicate in an exhaust system, over a period of time they are likely to go wrong. Carbon build-up is what kills this system of vanes, and they start to jam up. Your ECU on your modern car is a relatively clever piece of computing equipment, and it will measure lots of different parameters as you are driving down the road. There will be a mass airflow sensor, a manifold pressure sensor, and a throttle position sensor, all operating together. And the ECU will measure all of these readings, and for as long as they are within its expected parameters, all's well. But when you put your throttle down and one of the parameters falls out of what's expected, the ECU will put the car into what's called limp mode, which is a protection device. It stops damage to the engine. The short version is, if a car with a VNT system was to spend its life going up and down a motorway at 70 miles an hour and the exhaust system was red hot all of the time, that would never go wrong. However, an awful lot of these VNT type turbos are fitted to the sort of vehicles that might be used on stop-start journeys like school runs or being a delivery van around town or whatever. And that short stop-start journeys that the engine never gets hot, the exhaust system never gets hot, that's when carbon is built up excessively. The vanes will jam and the ECU will very regularly put the car into limp mode. For a car owner, what that means is if they take the car to their local dealer, the dealer will probably say, you need a new turbocharger, and they will fit a new turbocharger at many thousands of pounds. The car will be fixed and the owner will be happy, albeit poorer for the experience. But what we know is that there isn't necessarily anything wrong with the complete turbo, only this mechanism. And that mechanism can be cleaned and or changed separate to the entire turbo. So if a garage were to remove the turbo and send it to someone like us, then we can leave the rotating part of the turbo in one piece and just address the vanes, make the turbo work as it should again, and for probably a tenth of the cost of what a main dealer will replace the whole turbo.
And that takes me back to should we think of the turbo as different pieces as opposed to, well, my turbo needs fixing, as opposed to
this part.
Can you clean that part?
So this is a typical VW Audi diesel turbocharger. I mean, it could be any modern diesel, they're all very similar. The exhaust manifold is integral to the turbocharger itself. Your impeller and compressor side here, this is the exhaust side, so the exhaust gas is coming from your engine in through the manifold and out to the exhaust in this direction. Your turbine wheel is in here, and this is where the boost control system operates, the VNT. So if I do this, lift out this part of the turbocharger, there you can see the turbine wheel, and this is the series of vanes that we talk about. This ring is moving these blades around, and that directs the exhaust gas towards the wheel to make it spool up faster, or away from the wheel to allow it to slow down. Now there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 moving parts in here, and this sits in your exhaust system getting coated in oil and dirt and carbon and debris, and in a while they end up looking like this, and this is what I've taken from a used turbocharger. Now you can see these are somewhat less free flowing and free moving, and all of this here is what's stopping it working properly. And if this was heated up to 600-700 degrees, it would burn all of that off and it would be okay. But when you do short journeys and stop-start motoring, it doesn't get the chance to burn off. It just builds up and gets worse and worse and worse until it stops working altogether.
Something I didn't know existed
but I have heard little bits about. What is a hybrid turbo, and what's the difference?
Okay, so yeah, there is some confusion because of hybrid cars and the word being, hybrid being used a lot. However, in regard to turbochargers, when we talk about hybrid, what that basically means is it is a externally standard turbocharger, but with non-standard parts fitted inside. So let's say you might have a standard turbo for your car that makes 200 horsepower. At the other end of the spectrum, you might have a super duper ball bearing performance turbo Garrett GTX Gen 2 that makes 600 horsepower. And you might initially ask me, can I bolt a bigger turbocharger to my car? And you could, if you were willing to change the exhaust manifold, downpipe, pipe work, possibly ECU, do lots and lots of work. And in that instance, the turbocharger isn't the expensive bit, it's all the other stuff that adds up to a lot of money. So what we can present you with is what's called a hybrid turbo, which externally is standard, so it fits on your car exactly as your old one came off. But because it's been modified internally, it may have bigger turbine wheel, bigger compressor wheel, and uprated thrust bearing. It has the flow characteristics of a larger turbo, but in the package of the standard turbo. So you may be able to get to, say, 400 horsepower from your 200 horsepower without having to change all of the other bits and pieces. So what we are looking at here is a hybrid turbo that we are selling, and this is for the Nissan Skyline RB25. Now, the reason we're looking at this is so that you can see what the difference between a standard and a hybrid turbo is. Now, this turbine housing, and this is the turbine wheel, this is as a hybrid. This here, that I'll put side by side, is what the standard turbine wheel in the turbine housing is. Now you should be able to see that the hybrid has a much bigger turbine wheel than what the standard is. But note that externally the two housings are exactly the same. So what that means is the customer can remove this turbocharger, fit this turbocharger, increase the potential horsepower by a couple of hundred horsepower, but externally the turbo remains the same. It's a plug and play arrangement, if you like. It's the same with the compressor end, standard compressor wheel, much larger billet version on the hybrid. So this is an example, but the basic principle of all hybrid turbos is that externally they fit as standard, and then internally they are modified for a much greater flow. So if I flip them both over and do the same with the compressor side, that's the diameter of this one, and this is a standard Common Garden cast wheel, and this is a much larger wheel and billet construction, flows a great deal more, so you get the upgraded performance package in the standard turbocharger frame.
So okay, so if I fit a hybrid turbo, how much power could I get, and how is that anything to do with mapping?
Yes. So to make power from our engine, we need to burn fuel and air in a fixed ratio. That ratio you cannot change. You can put the biggest injectors and biggest fuel pump on your car, but you will reach a point where you can't make any more power. You can put the biggest turbocharger in the world on your engine, but you will reach a point where you're not making any more power. You always have to add fuel and air together. So when you fit your hybrid turbo, what that is doing is giving you the potential to make more power because it is producing more air than what your standard one was. And the power that you end up making will depend on adding fuel at the according rate. So if you get 30% more air from your hybrid, you will need to add 30% more fuel. But we won't know necessarily what other restrictions there might be. Maybe your exhaust manifold is a restriction, maybe your cylinder head is a restriction, maybe your intercooler is a restriction, maybe your mass airflow meter or whatever. You know, there will be other areas that we don't necessarily know. But we can say that this air pump, which is what a turbocharger is, will flow X amount more air. So when we talk about upgrading with turbochargers, one of the most common upgrades is to fit what is called a 360-degree thrust bearing. So this is the conventional thrust bearing arrangement, and you'll see that the thrust bearing itself looks somewhat like a Pac-Man, and it measures 270 degrees. This is a 360-degree thrust bearing, so called because the bearing surface goes all the way around 360 degrees. Now, what you might ask yourself is, well, if this is better than that, why don't turbos have these in all the time as standard? Well, the reason is to do with the manufacture. This thrust collar is turned out of one solid piece of material, and this is made out of two separate pieces. And the fit from this part to this part is absolutely critical to the balance of the turbocharger. And to manufacture that in two pieces and keep it so that it turns concentrically is very, very difficult to do, and is therefore relatively quite expensive. This is probably five times as expensive to make as this, which is why on a standard application you get this bearing. But when we build a turbocharger that is an upgrade or a hybrid turbo, they'll always be fitted with a 360-degree thrust bearing. The second upgrade that we will do as a matter of course is fit this type of piston ring. Now, what you may or may not be able to see is this has overlapping ends on the ring. It's what's called a stepped gap or a staggered gap piston ring, or sometimes called a total seal piston ring, so that when it is squeezed up together, the ends overlap and reduce the amount of likelihood that it will leak oil. It's a type of labyrinth seal in effect. So whereas the conventional piston ring just has two square butted ends, this has an overlapping end. So between the 360-degree thrust bearing and the stepped gap piston ring, we can improve the longevity, reliability and performance of the upgraded turbocharger.
I've got oil on my pipes, I've got, there's a lack of boost, a lack of power, there's a screeching noise, it's all of that. Oh my God, my turbo's broken somehow. Is that how turbo problems present?
So, you can have some of the things that you mention and it not be a turbocharger failure. Oil in your pipework, for example, looking at that one. If there is oil in the inlet pipework that goes from the air filter into the turbo, that oil must be coming from an engine breather. As the turbo is sucking air in, the oil won't travel upstream against the flow of the air. So if you've got oil in the pipework upstream of the turbocharger, that isn't a turbo failure, that is something else causing the oil to get there. A lack of power, again, that could be a turbocharger failure, but it may not be. Power is derived, as we said earlier, from fuel and air. So if your engine isn't delivering the fuel, you may not get power. So a lack of power isn't necessarily a turbo failure. Screeching noises. If when you accelerate hard and you hear a high-pitched screech that may sound like metal on metal, it probably isn't. What that's more likely to be is a manifold gasket leak. If you imagine the manifold and joints joined together with a gasket in between is not unlike blowing a blade of grass through your thumbs and you can make a screechy noise. We get that a lot where people have said, I got this high-pitched screech, is it my turbocharger failure? No, it's probably just a gasket leak. So a lot of things can go wrong that may superficially seem like a turbocharger failure, but actually they may not be.
Okay, how often do you get, but how often does it come up when people present with an expensive, a 20 grand engine, and they say, I'd like to stick a 300 quid turbo on that. Is that going to enhance it? Will that work with it? Is there any point to that?
It happens, sadly, quite often where people will aspire to make a brilliant race car engine, fast road car. They will plough many thousands. 20,000 may not even be that much. People can spend an awful lot of money building a really good engine, and they'll start from having all the right ingredients, the crankshaft, camshaft, pistons, all these bits and pieces, head work. They'll spend many, many tens of thousands of pounds putting this thing together. And they are right at the finish line. And they'll phone up and say, I want a turbocharger. And we can say, right, this particular turbo is exactly what you want. It's a proper ball-bearing performance turbo. It is the best thing for the job. And it will be, maybe it's £1,000, maybe it's £2,000. And they go, I've run out of money. I don't want to spend that. Can I buy a £300 turbo off of eBay? And it's an unfortunate thing because I understand it. I've had projects, I've been there and I've done that. But the reality is the turbocharger is the one component that is going to greatest affect how the car drives. A good quality turbocharger is going to enhance that engine and it's going to make it a really nice car to drive, whereas a cheap and nasty turbo is not. And to see what is potentially something really good ruined by the fact that a turbocharger has been put on there that is not enhancing it, it's in fact detracting from all of that previous work. And the difference between, a cheap and nasty turbo and a seemingly expensive turbo, yes, could be £1,000, could be 1,500 quid. But when you've already spent 10 times that, it's just the wrong decision to make. You really do need to dig deep and put something on that engine that is going to enhance it and going to make all that money worthwhile. Because myself and my partner, we're both into cars, into motorbikes, we're into projects. It doesn't matter if you phone me up 5 times, 10 times, over 6 months, a year, 2 years. Pick my brains, speak to us, we'll help you. We do not expect to sell a turbocharger on every single phone call we get. And we would rather invest some time in making that customer happy, and he will then sing our praises and say, hey, give those guys a call, they're helpful. All we ever want is to have happy customers driving the best cars that they can drive.
And better information makes for better decisions.
Absolutely, yeah.
Where do you see the future development of turbo units, or is it always going to be top-end sports? That's its home, and there is the obvious bleed out into other.
No, there will always be, I suspect, 2 different types of turbocharged vehicle. One is performance orientated and one isn't. There are more and more turbochargers on the not performance side of the market, if you like, because emissions is ever increasing the demand on car manufacturers to produce something that is very powerful, very economic, with very little displacement and very little emissions, and a turbocharger is a way of doing that. And in the performance car market, it's just about how do you make the most power you can, and a turbocharger is a way of doing that. For us in the business, things are changing where years ago there would have been much more fixing things, taking them apart, you know, the turbos were more serviceable. The more and more modern they are, it tends to be a question of either changing complete units or changing parts of. There's less of the take it apart, fits and bearings, put it back together. Mostly because they are so small and they are trying so hard in their little housings, spinning at 200,000 RPM, that when they do break, they break so catastrophically that there's nothing actually left to fix. You know, you're literally putting a whole new core assembly in the housings because there ain't nothing left of the old one. So that's changed. I mean, the remanufacturing side of it is still there, but less so than it would have been 20 years ago. Just while we're in the workshop, this rather grubby looking turbocharger, for those in the know, this is an RS500 Cosworth, a T4 turbocharger. This is from an original RS500 touring car, original race car. A pretty well-known car, certainly a household name, but I'm not going to say whose it is out of respect to them. We've done probably 15 or 20 of these RS500 T4s this year. We are fortunate enough to do the majority of the turbos for the new Heritage Saloon Car Championship, and this is one of those cars. So hopefully before this leaves us, it will be all spanking and new and original and ready to race once again. But I thought you might like to see it while you're here.
Right, well, I think that was a clean, clear, concise update on all things turbo. Thank you very much, Mark.
Absolute pleasure.